dear student. Okay, today we'll be looking at finite element method under structural elements. This is for engineering students, for those studying structural mechanics, those offering courses in structural mechanics. I've just want to touch something here under finite element that will aid you in your calculations under finite element in your test, your exam, because your test, your exam is being timed. In other words, you are there's time frame for your test and exam, so you are expected to work within the time frame given to you in your exam and test. Now, the finite element method, I just came up with something with a trick that I want us to know about. So, we know for the finite elements, we have the formula for finite element being K and F. So we have here the matrix K multiplying the D being the displacement vector and the displacement force itself element method, where our K is the global stiffness. Is a matrix, global stiffness matrix. Our D is the nodal vector or nodal displacement vector. Yeah. Nodal displacement vector. And our F is the force vector. This analysis is normally done for structural elements, for the beam, for our beam, and this method is used to simulate the structural element. In other words, it considers the force acting at every section of the structure. So, okay, let's go this way. So, what I wanted to bring to see in this morning is, or to notice this morning, is this our K being the global stiffness matrix. Because normally, if you don't know the shortcut or the standard formula for it as a student, if you are to analyze it in the exam or test, before you finish the analysis, time is gone, but there is probability you may not be able to get the exact formula if you are to analyze it. It will take you over an hour, and if you make any error along the process, it will definitely affect your answer during your calculation. So, our global stiffness factor K has the formula EI over LQ into is a vector, is a matrix. It's a matrix. Our global stiffness K has the formula EI over LQ, then the entire matrix itself, where our E is the Young modulus, our I is our moment of inertia, and our L is the length of the section or the length of the beam in consideration. So, this matrix is what I want us to look at, the standard formula. So, you are expected, or I expect you to memorize it, because it's definitely going to help you in your test or your exams to save your time. For the first row, we have 12, 6 minus 12 and second row, we have 6, 4, minus 6, and 2. Okay? From here, because there are 4 rows and 4 columns for the matrix, first of all, I would like us to know that all 2 and 4 carries L squared. All 2 and 4 carries L squared. So wherever you see 4 and 2, add L squared. L squared. Okay. Then wherever you see 6 carry L. So add L. So wherever you find 6, Good. So, from here, we need to get our third and fourth row. So to get our third row, replace or repeat what you have in the first row. 12, 6L minus 12, 6L. We repeat it. After repeating, then multiply the row with minus 1. Multiply the row with minus 1. Minus 1 times this will give us minus this. Here we come plus, so let us erase this minus. And here it give us minus. Okay, we are done with third row. Then for the fourth row, rewrite second row. Bring this second row to the fourth row. Then interchange the position of 4L squared and 2L squared. What do I mean? 6L, 4L squared minus 6L, 2L squared. Interchange. Reverse their position. So here we give us 2L squared, and here is 4L squared. This is to save your time. This is a cheat code to help you to save your time in the exam. If you are able to grab the table in your memory with the way I've explained it, you'll be able to analyze the beam efficiently and successfully without time wasting in the exam or test. Thank you for watching, and I guess you guys got valuable time. Do well to subscribe to my channel and do well to like and follow for more updates.